Hello, I'm Dr. Frank Gupton, founder and scientific director of the Medicines for All Institute at Virginia Commonwealth University, and I welcome you to this webinar. At Medicines for All, our goal is to empower access to safe, effective, and affordable medications, and our hope is that this webinar will provide the manufacturing community information and insights on how we are addressing primary cost drivers for global health medications. Manufacturers who want additional details and/or learning more on how they can adopt our processes should reach out to us at mforall@vcu.edu. Thank you.
Welcome to the Medicines for All lamivudine and emtricitabine webinar. In the next few minutes, we will share our process to lower the cost of production of the HIV medications lamivudine, also known as 3TC, and emtricitabine, also known as FTC. Before we continue, I would like to take a moment to introduce our institute. Medicines for All, or M4All, is an institute within Virginia Commonwealth University, largely funded by the Bill and Melinda Gates Foundation. Our mission is simple: combine academic ingenuity and industry practicality to improve access to safe, effective, and affordable medicines. We achieve this goal by designing low-cost, scalable, and green processes for critical active pharmaceutical ingredients. This is why our institute is staffed with principal investigators and scientists with decades of industrial experience. All high-volume ARV regimens contain either 3TC or FTC. These two APIs are also included in many second-line, pediatric, PEP, and PrEP formulations. The required daily dosage is high, 300 mg per day for 3TC and 200 mg per day for FTC, and makes these APIs a key cost driver in every high-volume ARV regimen on the market. The cost reduction for 3TC and FTC would increase accessibility in low to middle-income countries and ensure the market for these medicines remains robust. The current manufacturing process is a 5-step process developed by Andrew Whitehead and colleagues at GSK in 1995. Though a number of synthetic approaches have been disclosed, the original synthesis appears to still be practiced today with only minor modifications. The process begins with the esterification of glyoxylic acid with L-menthol to give the corresponding menthol ester, condensation of dithienediol upon the menthol ester, and subsequent dynamic kinetic resolution using triethylamine and heptanes gives the desired stereoisomer of the key hydroxyoxyethylene intermediate. Recent findings from Lupin indicate that the diastereomeric ratio is not a critical parameter in transformation to the final API, and thus the DKR step may not be necessary. Chlorination of the hydroxyoxyethylene and an SN2 reaction with cytosine gives the penultimate intermediate to the API. A reduction with sodium borohydride delivers the final API. A similar process is employed for the synthesis of FTC, with 5-fluorocytosine used in the place of cytosine. Impressively, the cost of goods for these reagents is relatively inexpensive. M4All considered low-cost, commodity feedstocks and identified the hydroxyoxyethylene intermediate as an opportunity to lower the cost of both 3TC and FTC. In this webinar, we describe a new route to the hydroxyoxyethylene compound. The route replaces glyoxylate hydrate and dithienediol with easy and cheap-to-source materials, vinyl acetate, thioglycolic acid, and sulfuryl chloride to construct the oxyethylene ring. The process begins with esterification of thioglycolic acid with L-menthol. Addition of vinyl acetate to an in situ generated sulfenyl chloride gives the monochlorinated sulfide ester, where this intermediate undergoes alpha chlorination to give the dichlorinated intermediate. Ring closure is achieved by unmasking the aldehyde via transesterification to give the key hydroxyoxyethylene intermediate in approximately 50% yield. This process improvement relates to a known intermediate and is a drop-in replacement to the current manufacturing route, and the route change does not occur within most regulatory defined routes. We expect that these factors will facilitate the ability to adopt the technology and lead to improved pricing of 3TC and FTC. The current market price of the key hydroxyoxyethylene intermediate is $34 per kilogram. M4All's route is estimated to deliver the hydroxyoxyethylene intermediate for $27 per kilogram, a 20% cost reduction. Using the price of this intermediate, the estimated price of 3TC would be $120 per kilogram compared to the current market price of $140 per kilogram. Further, using both M4All's process improvements for the hydroxyoxyethylene and the previously reported process for 5FC could lead to a price of FTC for as low as $165 per kilogram compared to the current market price of $230 per kilogram. Inferall will release a process development report in early April 2020. The PDR describes the process in detail. All administrative and technical questions should be directed to inferall@vcu.edu. The Inferall team would like to thank you for joining us.